self-inductance. As we have already known that there are EMF generation or induced EMF if the magnetic flux would change, that we have already learned. Now suppose I have a coil, and in that coil I am giving a certain current which is suppose connected with a key, and this is a certain coil. Whenever I press the key, the current goes through it, and this current, suppose if this current changes, if I can regulate this current, and if I change the current passing through this circuit, then what happens? This current, changes in this current would produce a change in magnetic flux through this coil. So if there is a change in magnetic flux, suppose the magnetic flux is B, and if there is a change in magnetic flux, then this change in magnetic flux, which is due to the change in current I, that change of magnetic flux would produce a kind of EMF, right? And this EMF we already know, suppose EMF E is produced here. From Faraday's law we know that this EMF is equal to d phi B by dt, right? Now when such EMF produces due to change in magnetic flux, and the change in magnetic flux is due to the change in current, we call this as a self-inductance. Now inside the coil, what happens is the change in magnetic flux is proportional to the current I, right? If the current changes, the magnetic flux would change, and there is a proportionality constant L for this particular coil, and we call it as self-inductance, right? So what we see that due to the change in current, there is a change in magnetic flux which would generate a EMF in that. Now this EMF would be, as per Lenz's law, we know that this EMF would try to stop the change in current. It means that it would try to stop to further producing any EMF, means it would try to stop the change of the magnetic flux, which in turn it means that it would try to stop the change in current. So using this property, where we see that there is this particular circuit element, what it is trying to do? It is trying to stop any changes of current. Why? Because there is a EMF generation, and we name it as back EMF. This back EMF, when in this circular coil there is a generation of back EMF, this back EMF is stopping or opposing the change of the magnetic flux, which means it is opposing any change of the current that is happening in the circuit. It means that this back EMF of this particular circuit or the element of the circuit is actually opposing any change of the current. So this property is used, and this property this particular element is what is called an inductor. This is a very important circuit element when we study electrical and electronics, and this circuit element has a particular inductance L. Every inductors have a particular inductance or self-inductance L. And this inductors, what is their general work, what is their general property? They would try to stop any kind of change that occurs in the current in that particular circuit. So generally this inductance, every inductor is certified with a particular inductance or L. This is named as L. The SI unit of inductance is Henry. And if you just try to put it in the back EMF, this is the back EMF as we have told. So if you try to put this here, we can say that E is minus d phi by dt, which means d by dt of L I, which means L di by dt. So this is the EMF produced. So this EMF will try to stop any kind of change in the current. Now if there is the current change is 1 ampere per second, if di by dt is 1 ampere per second, and that produces a back EMF of 1 volt, then the inductance is what is called 1 Henry. So the SI unit of 1 Henry can be defined as when there is a change in the coil of 1 ampere per second, which would produce a 1 volt of EMF, then the inductance of that particular inductor, we call it 1 Henry, right? So this is a very, very interesting thing where we see that the circuit element is opposing any kind of change of current in the circuit element. Now suppose this inductors, that's how these inductors are kind of like how we have resistors and capacitors, and resistors have resistance which doesn't allow the current to flow. Also we have capacitance for the capacitor. Same way inductors have this particular inductance, and their major role in the circuit is to nullify or to stop or to prevent any kind of change in current in the circuit. Now suppose if you give any kind of current through it, so therefore if there is any kind of current that is given to it, then there would be an EMF, and that EMF will be L di by dt. So this will be the EMF produced. And suppose if I give a DC current, so if there is a DC current given or an inductor is connected to a DC current, if this current is a DC current, then what happens? Then if any changes in DC current takes place, that would be stabilized by the inductor. So it won't allow any current, any fluctuations or any changes in DC current. Now coming to AC, if the current is AC, then what happens, as we know, we would also know that in AC, the current itself changes its direction. So if I give a AC current, what happens is, if there are we need a particular variation in AC, but there are multiple different variation in AC. Therefore, inductor in AC current, what it will do, whatever changes is needed, except that all the other unwanted changes in AC, it would nullify or stabilize, right? So this is what inductor will do. Now suppose if I give a current I, which doesn't have any change, a steady current. If I give a steady current, then this inductor wouldn't do anything, because the work of an inductor is to stop the change of the current. But if the current itself doesn't change, and if it is a steady current, then the inductor would pretty much be like a dormant element. It won't work anything. It won't do anything. So what we see is the inductors. That's how it's a very important element in the circuit, and we will come to know in future also the uses of inductor, where we see that if inductor is there and there is a current moving through it, then there would be a EMF produced, which we call the back EMF, and this EMF is due to the magnetic flux change, and this magnetic flux change is due to the change in the current in the circuit. So therefore the EMF directly linked to the change in the current of the circuit, and that is how this EMF would try to stop the current production it would stop the change if any change is happening in the current in the circuit. And this particular EMF we have called it as the back EMF.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.